All right, so pretty sure I know most everyone here, but if not, my name's James Ainsworth. I'm the director of the engineering team at Collier Aerospace, and I'm going to present a topic here about providing engineering services to our user community. And that's really a big theme of my presentation, is that we are, in fact, a community of stress analysts that use this stress tool, and we all get value out of everyone's use and everyone's input, including obviously our engineering team. And I'll be presenting this, but I have contributors here, everyone, because I think I bothered everyone on my team for an image or some input. So thank you guys for helping out and propping me up. Here's a little peek behind the curtain. This is a couple images of our engineering team hard at work. And I love these images because it really does show kind of a level of collaboration and excitement about the work that we do. And we are very excited to do work and to support you guys. We feel very honored and blessed that we get to work all of these amazing projects, and you guys give us a lot of fun, interesting problems to solve. So it's a really good time. It is a very collaborative work environment and very energetic, and the guys do a good job of working together and collaborating to solve problems. You know, you've heard my name a lot by a lot of the presenters, but I really feel compelled to say that, you know, it's really a team effort. It's our engineering team that provides you guys the great support and helps build the automation tools, the automations and methods team. And, you know, without a doubt, the software team that creates the software that we all use, right? Because without which we wouldn't have a user community. We'd have nothing to use, right? So the software is the automation tool that we all gather around to try to figure out, you know, the work and the problems that we're trying to solve. So, say what you want to say. All right. HyperX is a tool built for stress engineers, but it is built by professional software developers while being informed by the stress engineering community. And our stress engineers that are supporting all of you guys doing your very relevant, you know, aerospace programs. And I feel like that's a very powerful statement because that's very different from saying it's a stress tool built by stress engineers, right? Because, you know, don't take offense to this, stress analysts, you're probably not the best coders. And, you know, your software would be very specific to your application. And so the idea is having a professional software community of developers that can build a tool for us and take our input and our insights and put it into the software. That's very enabling. Our engineering team, the Collier Aerospace engineering team, we use cutting edge HyperX features, basically new features, kind of on the fringes of the tool. You know, and we also develop custom workflows to solve very unique problems with HyperX. And these are typically the type of problems that other companies may try to build some in-house stress tool or some in-house tool to solve. Well, HyperX is our in-house tool. That is what we use to solve all of these problems. And we put all of that tribal knowledge and all of that, what we learn of how to solve these problems, back into the tool in some form or fashion, right? That's always our goal, to capture this knowledge and put it back into the software. And we as HyperX users, we are a user community, right? Like I mentioned, we're all using this software tool in some form or fashion to solve different problems. And we all benefit from each other's use of the tool, whether that's helping it be more robust, or giving us insight into new problems to solve and new methods and new processes. And the Collier Aerospace engineering team provides value to all of the user community, just as you all do. And we provide value to the community even if you don't contract contract work with us. You're still benefiting from our existence and the value that we're providing. Here's a great example. You've heard a lot of presenters talk about this enterprise use case, this workflow for automating multiple users multiple engineers or different stress teams sizing and analyzing different portions of the same vehicle and then merging those back together. Well, that was a workflow that we saw as just a very common way of doing things. We noticed that in the community that everyone had this process that they were doing, and they were doing it with include files and non-automated ways, very manual, very error prone. So we collected all that knowledge and we went back to the software team and we said, we need to create a process around this. We need to create some automation and some capability around this. And now we can all benefit from that being in the software, right? So again, that's an example of how we're all benefiting from the existence of the Collier Engineering Services team, even if you don't contract work with us, as well as your input. Everyone that contributed to this and gave us that knowledge and collaborated with us and tested it out and provided feedback, you know, all of that gets put into this tool that we all get benefit from. So how do we use HyperX? When I say we, I'm now speaking for the Collier Engineering Services team. We use HyperX on large models, and not just large models, but complex models, and models that require a lot of organization and you know, a list of structures and sets and folders and subfolders and numbering and naming is all very important because we're maintaining these models over the course of many months. And to be able to, you know, work with this day in and day out, organization is paramount, right? And so we spend a lot of time organizing and reorganizing and numbering and taking stuff out of other tools, other pre and post processors, you know, other organizational entities in FEMAP and HyperMesh and those other tools, and pushing them into HyperX and syncing those tools up as well. So we spend a lot of time just maintaining and organizing these large models within the HyperX environment. We also do quite a bit of global stiffness optimization. And so there's kind of many levels to this and many ways that we pay attention to stiffness, you know, deflection and torsion, obviously, but as well as, you know, frequency and, you know, global section cut stiffnesses, flutter requirements, aeroelasticity, right? So we're always very aware of this and how the local HyperX optimization is affecting the stiffness. We're also very aware of the global stiffness requirements, the section EAs, EIs that we pull out and we map to the model, and we use those through the sizing process. And so this is very important to keep a global stiffness, keep it pretty consistent, and to get there quickly. Not only to keep it consistent, but to get to a representative stiffness model for your aircraft very quickly. Because everything is based on stiffness, right? Your aeroelastic loads are based on stiffness. A lot of your requirements, all of that is based on the global stiffness of the aircraft. And to be able to get to a stiffness size result very quickly and to keep it very consistent is important for not driving a lot of weight into your program late in the game, or, you know, just to nail down your loads and have those be very consistent throughout the project. We spend a lot of time with loads validation. We have a lot of new tools that have been developed over the past few months, and we use them quite often for getting out VMTs, or shear bending moment diagrams, say along a wing, making multiple section cuts within HyperX and pulling those loads. And in the upper right hand corner you see an enveloped plot of all of the design cases as the dots, and then the outer portion of it is the envelope of the max and the min horizontal bending moment on the wing, with the call outs of each corresponding design case that envelopes those. So super useful plotting, very good to overlay an old load set versus a new load set, or even test loads versus your envelope flight loads. And then where we can create these potato plots now that we use often for validating critical design loads at specific section cuts, and seeing, again, at the extents of the potato, the design cases that are kind of the maximum or the envelope of the combined torsion and moments. We do a lot with section analysis, and so there's kind of two really big things with section analysis. It's getting the section loads from your loads model, and in most cases, your loads model is far too coarse to get any meaningful geometry out of it. It is just that. It is a loads model, right? And you're trying to get the loads out of the loads model, and then you're trying to get the geometry out of the more true representation of the geometry. And in most cases, that would be, your full-featured CAD. And pulling that in and measuring it and getting the geometry and the dimensions out of your CAD or some other tool or wherever you're holding your as-produced geometry. And then we're merging that information into the HyperX analysis, right? So in essence, HyperX is sitting in between the loads FEM and your geometry model, right? And it's merging that information together to do stress analysis, to write stress margins. And I think this is very common in our industry, I would say. The aerospace industry is still very much on this global loads model paradigm and the CAD model containing the geometry. And the stress analyst's job is to merge those two together to create safety margins to assess failure. We do quite a bit of substructure. It's too far. There's been a lot of presentations about OML structure and skins, and I wanted to make sure everyone's aware that we use HyperX for all of it, including internal substructure, spars, ribs, frames, fasteners, clips, fittings, all of that, all of the internal portions of the FEM that it's not super elegant always to analyze these parts, and it's hard, and many months and lots of time and effort spent on this, right? It's not a pretty thing to do, and it's not always fun, but we use HyperX for this type of analysis, and it is very capable for doing this type of structures. We also do a lot with buckling carve-out models. So in many areas of your aircraft, it's no surprise that analytical buckling just doesn't get all the way there. It's not going to get all of the buckling modes. It's not going to get the full answer. So we supplement those stability margins with global buckling assessments. And so we have tools that will determine critical compression cases. Obviously based on HyperX buckling criterion, we can screen the cases very quickly, pare down from thousands of cases down to just a small handful, and then automatically create these free body models or carve out models and map loads, either with enforced displacements or grid point forces, and then we run solution 105 to determine global buckling, eigenvalues, and mode shapes. And we also then pull those back in to HyperX and kind of overlay those buckling modes with the rest of the margins and the rest of the structure in the viewport. So there's lots of use cases for this. I could go on and on about how we use this tool and how we use this process, but I would imagine that pretty much everyone in the audience has done something similar. So obviously another very common workflow that we also deal with, and with using HyperX as our in-house stress tool. We do quite a bit with spring models, discretely meshed fastener models where you've got multi-lap joints and springs in series to represent a single fastener, but to make sure that we can pull, bearing and tension and shear forces at each shear plane and transform those into, bearing and bearing bypass loads for each sheet that you're fastened through. And so we support, C-bush and spring elements and RBEs, and one of our future kind of things that we're going to be looking at is, supporting like a proper Ruttman fastener modeling technique. But the idea is still the same, is pulling loads at each spring location, at each fastener, writing, margins for each fastener. That's, fastener tension, shear, bending, pre-tension fasteners, however complex you want to get really. And then, also looking at the bearing and bearing bypass loads that the fastener is exerting against what it's fastened through, right? So this is not an uncommon thing. Obviously, it's very common in the industry. We're automating it, right? We're making something that was probably unpleasant in other tools. We're trying to make that as pleasant as using HyperX on other things, right? So taking advantage of all of the post-processing and visualization and reporting, with fasteners and bearing bypass type of analysis around fittings as well. We're also very experienced with looking at, major structural interfaces, so major load transfer items like lugs and clevises and pins. We developed, a fairly thorough analysis package that will analyze lugs and clevises, pins, the base plate of the clevis, does the complex bolt pattern around the base plate, and then again is taking that analysis, those analysis results, and displaying them back in the HyperX interface using all the niceties of, the watch window for visualizing or reporting margins, and then visualizing the margins on the model and reporting them all in the Excel, reports and everything that we're all used to. So hopefully what you're seeing are, examples of how you can take, kind of out of the box problems and apply those to HyperX via, automation tools and plug-in packages, and then eventually that could get rolled into native HyperX capability. So again, that's how we as an engineering department, that's how we view HyperX. HyperX is our tool to customize. It's our tool to do everything, right? And we can get access to all the loads and all the material properties, and we can get access to all the analysis inputs that we need to write margins for these, more complex processes, right? And it's not just we, it's you. You have just the same amount of capability through our APIs as we do as an engineering team. More recently, we've been developing fatigue methods. I would say we have a pretty robust stress life fatigue approach using a variety of different methods, an aggregate damage method, Miner's rule, as well as, kind of a Soderberg interaction criterion. And we take in the fatigue spectrum. We apply those as design cases and define a number of cycles. And then we can assess fatigue of, acreage parts or kind of around the details of fittings and fasteners and things like that, depending on your mesh density, of course, right? So there's nuances to everything, and this is no exception. You have to make sure your mesh density is capturing what you want, or if not, you have KT factors that capture the features that are not modeled and things like that. So we use HyperX as a lot of our customers do for kind of final margins of safety and the stress reporting that goes along with releasing parts to go off to be produced and to be incorporated onto the vehicle. We have custom stress report templates that we use in-house. We've helped our customers develop their own custom stress report template that works with the HyperX output. We're very familiar, and we can help you guys develop those as well. These are largely based on Excel. That's kind of the pattern that we're seeing now is, the stress report is not a dead document anymore. It's kind of a living document. It's a tool to help disposition, MRB issues downstream. It kind of lives with the part through its life cycle. And it's not just the stress reporting, right? Obviously, that's very important. But we want to take all of the stress analysis results, the HyperX database, the loads that were used to generate those margins, and we bundle those. It's not package anymore, it's bundle. So we bundle all of that together into a package, including, additional files. And the additional files would be, corresponding stress reports. And it would be whatever additional thing that you use to generate a margin that lives in your report, right? We bundle that all together, and we keep that as our engineering data to basically substantiate that part design. And later on, if you've got to pull this down and address some sort of non-conformance issue downstream, the idea is you unbundle it, open bundle. Got to work on that. We take it all down, we put it all in the machine, and the idea is you can press a button and get right back to the same margins that you left off. And a lot of times that's where most of the time is spent when you're addressing nonconformance issues, right? It's how do I generate the same results that I'm seeing here on this report, right? That's step one. And we're trying to get you there as quickly as possible and to automate that procedure. I mentioned nonconformances, but we do use HyperX often in this phase of the program where you've released all your parts and now you're fabricating and you're building and you're assembling, and lo and behold you've got non-compliance issues with your composite laminates. You've got waviness or wrinkles that have been detected on some of your parts. You've got quality issues with some of your parts. You've got misdrilled holes, which happens often, and the idea is you need to clear that part very quickly. You need to figure out, is this critical? Do I need to scrap this part, or can I repair it, or does it not matter? We'll just take this one, and this is in a high margin area, and I can prove that I still have positive margin with this defect. Just patch it and just keep going, right? So HyperX is our tool for that, and it has a lot of value for helping us support our customers in this phase of the program. We also do a lot of test support for our customers. Obviously, we don't build anything in-house, unfortunately, but we get to help our customers lay out their test plan, design test fixturing. What you're seeing here is a wiffle tree. I think maybe Jonathan Russell had a cooler image than that of the wiffle tree, but we do analysis of the frame and then determine the design of the wiffle tree to try to hit target VMTs at different stations, and then overlay those loads against our envelope flight loads to make sure that our test loads are enveloping our flight. We have automation tools for, we call it Test Like You Fly, which is taking all of your envelope flight margins and quickly ratioing those to your test margins to, again, quickly understand and visualize and see where you're over testing, see where you're under testing, and make very quick assessments about, do you need to change something about your test setup. This is enveloping. This should have come after the buckling slide. Anyway, very quickly, we use a feature called discrete fields to envelope buckling cases and deflection cases and merge them into one viewport, and to create call-outs and things like that to understand where buckling is critical and what modes are popping up, and envelope all modes below a certain eigenvalue. So very useful visualization tool. And then we automate customer-specific workflows using APIs. So this is probably one of the biggest benefits that we can provide you guys, your company, your stress team. We know a whole lot about how HyperX works and how it thinks, and we can help you by quickly figuring out the best way to insert HyperX in your workflow. And not only that, how to automate the data exchange between the other tools that you're using in your workflow. And one example of that is SimCenter 3D, which is very much a geometry-centric or geometry-focused tool. So all of the input for the properties and the zoning has to be done on the geometry, or you very quickly create an orphaned mesh, and you really don't get to take advantage of the power of SimCenter that way. So we can link HyperX up in that environment, create processes that will understand, the zone definition, redefinition that's coming out of SimCenter, and then passing information back, not directly to the mesh entities, but back to the CAD entities that are linked to the mesh. So it's an example of a workflow of linking HyperX up to it. But again, our team is not the professional software developers. We are the prototypers. We are the ones that can help you quickly address pain points, in your process. And I like using this image. Thanks, Brian. This is a very good visual to kind of help describe where we live as an engineering team and the problems we help you solve and how we work versus how our software team would solve a problem. And so this is the SpaceX Raptor engines and kind of the progression of the maturity of those engines. And what you see on the left is it's kind of a mess, right? But it gets the job done. You're not going to want to maintain that over a long period of time. It's probably a one and done kind of thing. But, as an engineer, sometimes you just get me an answer. Get me to the right answer and get me there quickly. And that's what we can help you do. We then work with our methods and automations team, who Noah is the head of that department. He'll be talking next. But they're kind of the in-between, right? So they'll help clean things up, and they'll take our prototype and, in most cases, throw it away and start again in a better tool and make a better product and something that's more maintainable and more usable for more general use, using our APIs and our plugins and scripting API. Then obviously you have the most robust portion, which would be the software developers, the professional software team that creates the robust software that's very general, that works and never has bugs in it. And it's tested for a lot of the boundaries that we just don't worry about when we're trying to create a very specific tool on the engineering side. So with that in mind, here's a quick summary of how we collaborate with our internal departments. And this is what you see as a customer. You say, I need some help. I've got all this work and I need to set up studies and do trades and do sizing and analysis. Let me contact the Collier Engineering Services team. We work together. We collaborate with you. I stole this from you. Thanks. We work with your team and, take your model. We help you organize it very quickly, do FIM inspections, make sure it's going to work really well in HyperX, and work with your FIM team to make it really HyperX friendly and, help you very quickly get to sized, structure with strength margins and everything you need for that. And then, in many cases, you kind of wonder, well, I've got this other problem. Can you help? Right? Can your team help me analyze this new thing or this unique thing? And I like using lugs and clevises as an example. And we say, sure, we can help. So we'll go off and do some methods research and a lot of times develop a very quick prototype. Excel's kind of our go-to for stuff like that. We develop an Excel tool to see if we get the right answers or get the same answers as the methods that we're researching. We then collaborate with you. We say, hey, is this right? Is this what you would do? We talk to our subject matter SMEs, our industry SMEs, and they say, yeah, it's good enough. Not what I would do, but you guys are doing a good job. Just keep on. It's about all you get out of them. And so we have a tool now, we have a process, right? And now we say, geez, we got to use this on many areas of the vehicle, and we've got to process hundreds or thousands or hundreds of thousands of load cases. We're not using Excel for that. We're not using this prototype. So what do we do? This is what you don't see as a customer for our company when you work with our team. You don't see all the internal stuff that we do to create a tool that we can now use on your project and provide you to use, right? As an engineering team, we work with our methods and automations team, and we say, hey, we need this plugin package, and they say, give us the methods, give us what you need, and we develop, methods documentation, and it describes everything that all the math and all the equations that we want to use, and then we create a prototype tool, and we provide that for testing and make sure we get, we get these candidate cases, we get the same answer. The methods team then goes to the software team and says, hey, I need something in the GUI. I need something exposed through the API to support this new thing, this new method, this new process. The software team asks the testing team to test this new feature, right? And then we all ask the customer support team to create documentation, user documentation, so that when we provide this back to our customers, they can actually use this feature, right? And so all of that effort is put back and given back to the engineering team to help us deliver, to help us, do analysis on your part, to deliver, strength margins and stress reports and everything like that. So, here's a software plugin with documentation and everything you need. It's well tested. Go impress the customer, right? That's what they tell us. And then customers happy. We provide you guys back, HyperX databases. We teach you guys how to use the processes and the tools. We, provide stress reports and all of that. And then you're happy. You can go off and update your CAD and go update your parts. So in essence, what I'm trying to say is, it is very much a collaborative effort when we support your teams and you guys as customers. It's not just the engineering services team, and it's not just the software team, and it's everybody. It's everyone in our company pitching in some way. And so the idea is we're taking these problems and these things that you're giving us, and we're figuring out the most useful things that we know that are kind of cross-company, cross-platform, that should be rolled in as native core HyperX capabilities. And then that gets rolled out and delivered to you, our user community, as new features and capability that you all now have at your disposal to go solve problems. So again, we all benefit, not just from the existence of the software team, not just from our engineering services team and our methods department. We benefit from everyone's use of the tool and everyone's feedback. So we do appreciate it, and that's it. Kind of a hard stop. I don't know. Do I have time for questions? I saw the red light like 15 minutes ago. Yeah, I understand if there's no questions. Well, Misha's got one.
Actually, not a question, just a comment on that. Obviously, James pointed out that the engineering services team, if you work with them, a phenomenal way to get any of your needs, requirements, challenges met. I wanted to point out to those of our customers who aren't using engineering services and just use the software, as one of our presenters showed yesterday, please let us know if you have, these challenges, these needs, these little things that you think would help, because there's a high likelihood that the engineering services team is doing stuff like that. And when we hear that 2, 3, 5 of our customers would love that feature, well, we're a niche company. We very much like making those things happen. So please, even if you're not using our engineering services, please let us know how we can support you. Just throwing that out.
Thank you. I think Logan's got a question.
More of a, not really a question, but a request. Can you send this presentation to
Yes.
to us?
Yeah, this will be in the package. All these images there's nothing on here that's export controlled. So.
Okay. Yeah, I think it'd be really beneficial.